So, welcome. This is going to be a weird, long-ass tutorial, but I want to talk about UIs. So I've been building a lot of these highly specialized tools for mostly for videos, but mainly just for shows to get some weird sync shit going on, like map modular synthesizers to Resolume, control a camera that's on a reel. Let's see, the ultimate Resolume controller. Color Addict. This is basically Yoris's app, but you can pick and choose colors for Resolume. It's really nifty. It's like, why would anyone need that? This is really useful, as it turns out. This is actually just built this one. It's a kick snare extractor. If you throw in most drum and bass or dubstep music, it can fairly most of the time detect what is a kick, what is a snare, and it will instantly do that. And yeah, you can send over these envelope followers to OSC. Most of these apps are OSC based, but they all have one thing in common. They're made pretty much the same way, with the same workflow. Basically, they have a lot of objects, and they are all just one max batch. Well, not just one, but all these panels above here, for example, this is just one max batch that's loaded in a bunch of times in a B patcher. This is just one max batch. These are all just one, yeah, you get it. These are 32 envelope followers to map incoming, again, modular synthesizer performance from Colère, map it to 32 speakers in Resolume again. So these are 32 envelope followers, and they transform the signal to OSC, so we can basically do funky, syncy shit with it. Alright, and yeah. So this patch is pretty basic. It was actually quite easy to make, but the thing is, I have to change a bunch of stuff because this is basically just a prototype. We're going to write it in C++ later on. So right now we're figuring out all kinds of things like how do you fill a panel? Do you have to double tap it? Do you have to press your finger for 3 seconds? I don't know. We tried a bunch of stuff. Also, yeah, so every time I want to change something, I don't want to change every 40 of these panels. That would be hell. And honestly, I couldn't do it because, yeah, you tend to make mistakes if you do repetitive work like this. So, yeah, I had to figure out a way to change them on the fly because ideas are flowing daily. Yeah, let's open one of these panels. And yeah, the reason I'm saying one of these panels is there's only just one panel. All these panels are just one object, and they all have their initial values. And I've loaded them in, through a script, basically. So I didn't even have to create them manually, place them manually. That's all a script that does it for me. And this is one of the objects. So if I want to change something on the fly, I don't know what to change. Let's change the background color, for example. Blue. Seriously ugly. Let's save it. Save one panel. Yeah, sure. I thought that was already there. And voila. It's really ugly. But the thing is, I only had to change one thing in one max patch, and it automatically updated each and every one of them. Cool. So this is one example, and I want to show you some more. just to get sort of the basic idea behind this going, and also to kind of make a point why this is so important to patch like this and not to patch like what I have been doing for quite a while. As to, I need some toggles, let's create some toggles. I don't know, let's attach them to the gate. This is me 6 years ago creating a sequencer. Anyway, you get the picture. As soon as I have to edit this, I have to edit one, delete the rest, copy paste it over, and make sure I never ever have to edit it again because it's horrible. Cool, another one. Let's go to the DMX mapper. So basically we wanted to control some lights as well, because we do we've been doing visuals for quite a while on events, and after a while you also want to control more stuff than LED displays, I guess. So one way to control lights, like moving heads or whatever, is by DMX or by ArtNet, and each individual light has its set of parameters, basically its channels. These are fixed, and you can find fixtures for each individual light that's ever been released that tells you how many channels, what does the channel do, etc. So if we want to control, let's say, a moving head from whatever brand, you just look up the fixture and make sure you're standing out with the right channel offset. Let's have a look at the DMX loader. No, not the DMX loader, the fixture loader. So, no, not that one. Let's see, fixture loader. Yeah. It's probably gonna load in an XML because it saved the last XML that you dropped in. There we are. But we don't want that. We want to create a new set of sliders with this other XML. There we go. So as soon as I drag the XML, the fixture file on it, it creates new sliders. These are actual sliders, but not your ordinary sliders. So there's a whole bunch going on, and as you can see, it has the index number of the channel. So you know color fine is actually channel 13. You scroll down, we have, FX speed on 23. So the basic idea is to send these sliders as a list out over ArtNet, and as soon as you connect this particular light, you can actually control all the parameters with this patch. So let's have a look inside. Let's see. I think it's fixture loader. No. It could be, bear with me, fixture creator. That's the one. Yeah, it needs to load in. Cool. This is the actual patch. So what happens, it all starts with dropping in a file. You can forget this bit. This just saves the last path from the file that you dropped in. So as soon as you open the patch again, it's going to load up the last fixture you dropped in. So first things first, it's going to open. Then it's going to, forget this part. This is the important bit. This is this object. It's really useful if you want to parse XML. Also, there isn't really any other way to do it. I think Saddam has a see. Yeah, I deleted those files because they didn't run on 64-bit. Anyway, we parse or we route ID offset. We prepend offset again. We prepend ID again. This is just a way to route it, but leave the actual initial routing argument intact. Because if we have a look at the XML, let's go down a bit to see where the, so we have range, all the parts that say range and value. The value, especially, they give me the name. So what I'm doing here is ID offset. No, wait, sorry. Let's have a look. Let's look for ID point. All right, let's look for offset. Ooh. Right, yeah, so it's actually the offset that gives me the index number, and then it's ID that gives me the name of the channel, what it does. So what I'm doing is, as soon as if a tree hits the word offset, I'm rounding the index number, and then I'm routing the ID. Running that, slicing it, I'm filtering some stuff that was in the way. There's no exact science to this. It's just basically parse until you get the correct trees, and test it out with lots of other XMLs to really see if you did it correctly. So what it does is every time it finds it finds a channel, basically a channel. So what it does is, first off, we destroy the initial slider object that we created first. So right now there are currently a lot of B patches, and when I say object, I really mean just a B patch here with patch in it. So we have a lot of B patches here. If I were to create new sliders or new B patches, they would basically go on top of these, and you'll create double ones that you're not going to use. So that's the whole point of getting rid of them as soon as you load in an XML, so we can start off fresh. So that happens first. And then, basically, let me explain. I am creating a big list that's going into dispatcher, and it basically tells dispatcher to create a bunch of B patches. These B patches have arguments in them. They have 5 arguments in them. So they have a comment, they have a send name, a receive name, an index number, and a call name. And then the 6th variable is just the offset that we want to give. Otherwise, they'd be stacked on top of each other. Let's get rid of that one and drop in an XML. Oop. You'll see what happens if something happens. Wait, did I load in? Yeah, I load in the Robin Speeder. That's a huge fixture. It's the biggest one I found. I actually started looking for like the biggest fixtures. Anyway, so he placed all these B patches on top of each other. We don't want that. That's horrible. So what that part does, it basically creates an offset for each of the B patches. A var name, that's really important, because the kill message only works with the scripting name. So basically what you say is delete script, delete with the scripting name. So I give a scripting name. Basically, it's kill and the index number. So let's load in a smaller XML. It's going to create all the B patches now. Ooh, yeah, they're still on top of each other. Hit. So all of these B patches, they each have their own unique scripting name. And with this scripting name, I am destroying them. Ha-ha. So yeah, this kill 1, kill 2, kill 3, and as soon as I load in a different fixture, this script is going to run. It's going to count. It's going to count basically. And with sprintf, I am actually deleting them all. And that's basically it. Yeah, we can have a look at the slider object, the B patcher. Slider. So this is the B patcher you saw earlier. It's basically a slider, but as soon as you hit map, it changes to this view where you can map it to different input channels. These input channels, they all come from a call message and yada yada yada. Basically, it's a slider. That's it. It sends out its integer, and it prepends the index number, I think. Yeah, so #full, index number, and then it sends it out over the variable send name. And that's it. Cool. Okay, so let's go back to fixture creator. You'll see that I am creating send and receive names here. They're also with a #1. That's because fixture creator, this patch that we're looking at right now, is also, I'm using it as a B patcher with arguments. And this B patcher creates other B patches. So they're nested B patches. Sounds way confusing and convoluted, but I assure you it's great. Don't save it. So let's go back to the main patch, basically, where we call this this nested B patcher. I think it's fixture loader. Yeah, it's this one. It's loading in the XML. There it is. This is actually no, that's just a drop file. This is the, I don't know what that. Here it is. This is a B patcher called fixture creator, and the first and the second arguments are DMX2, DMX2. So when I mentioned earlier the #1 for the send and receive names, these are filled with DMX2 and DMX2. So basically what I do is I create a fixture loader with send and receive names. So currently all these sliders are sending their output over a send object called DMX2. I'm not sure. Let's check it out. Oh, my computer is having a hard time, I think. So it's not in. Maybe it's out. Or actually, maybe it's just DMX2. Yeah, boy. Okay. So what you see is the first number is the index number, 7, and the second number is its actual value. So what we can do, funny thing with multi-slider, is we can prepend set. So it's going to take the index number, it's going to use it as a set message, and the actual value is going to be the value controlling the slider. And now we have them all together again. Got 23 sliders, so let's set that one to 23 as well. Of course you can get the actual size and have it adapt to the actual size, but I'm not going to bother right now. Yeah. And if we want to get it as a list, because it's setting, we have to trigger bang list. We have to set it and we have to bang it. Just a little hot tip. And there we have it as a list again. And this list we can send over ArtNet. And yeah, that's that's one way to do it, and I actually really like this way. So yeah, let's build our own. So adios. Stay tuned for the next one when we're actually gonna get our hands dirty, maybe patch a bit. Ciao.